Hello friends. So let's talk about the type 1 and type 2 errors and power. Because statistics are based on a sample of the population, decisions based on those statistics could be wrong. So what are the consequences of a wrong decision and how do we minimize the chances of making a wrong decision? First, let's consider the outcomes of a hypothesis test. If the null hypothesis is true, and we fail to reject it, so we make a correct decision. If the null hypothesis is false and we reject it, we also make a correct decision. However, if the null hypothesis is true and we reject it, so we make a type 1 error. And if the hypothesis is false and we fail to reject it, so we make a type 2 error. Now think about the power solvent, where the R&D is comparing the fuel consumption achieved with their solvent to the industry standard of 3.10. Here, the null hypothesis states that μ equals 3.10. The alternative hypothesis states that μ doesn't equal 3.10. So, what conclusions could we draw in the raw that would result in a type 1 or type 2 error? Recall that we make a type 1 error if we reject a null hypothesis when it is true. The probability of making a type 1 error is on 4. Remember, when we make a type 2 error, we fail to reject the null hypothesis even thought it is false. The probability of making a type 2 error is donated by beta. Reducing alpha increases beta. Conversely, increasing alpha decreases beta. How can we increase our chances? How can we increase our chances of correctly rejecting the null hypothesis? We can do this by increasing power. Power is likelihood that we will find a significant effect when one exists. Power is 1 minus beta. To discuss power in more depth, let's consider how power solvent compares to similar products already on the market. These factors will affect the power of their test, the sample size, the population differences, the variability, and uh, alpha level. Of all the factors affecting power, we have the most control over the sample size. As sample size increases, the power increases, and we are more likely to correctly rejecting the null hypothesis. For example, suppose the R&D compares the effects of power solvent and competitor brand of solvent on 15 test subjects. If they decide to increase the sample size to test 30 subjects, they will have more information about their population and will therefore be more likely to make the correct decision about the null hypothesis. The magnitude of the population effect or how different the two populations are from each other also influences the power. The less different the populations are, the more difficult it is to detect a difference when one really exists. Therefore, power decreases. For example, power solvent compares its fuel consumption with a competitor's on a same car. If the fuel consumption differs significantly, then this difference is easy to detect. For example, consider population of a car applied power solvent. If the population mean fuel consumption is really 3.10 or 0.15 and the population doesn't have much variability, we are likely to obtain a sample mean value that is below to 3.15. But if the population has a lot of variability, we are more likely to obtain a sample mean value that is larger or smaller than 3.15. Therefore, population parameters are estimated with less precision when the population has more variation. We are less likely to detect a difference when one exists. Finally, on four of the level of significance influences the power of the hypothesis test. Remember that we control the on-4 level. The most common on-4 level is 0.05, which means that we are willing to accept 5% chance of that we incorrectly reject the null hypothesis. For example, power solvent is compared to the competitor brand. If on 4 is set at 0.01 and the p-value is 0.03838, we fail to reject the null hypothesis that the two solvent suppliers have the same fuel consumption. But if the on4 is set at 0.0505, we reject the null hypothesis. When we set on far higher, we are more likely to correctly reject a false null hypothesis. Let's review. Sampling can lead to two kinds of errors when we conduct a hypothesis test: type 1 and type 2 errors. A type 1 error is rejecting a true null hypothesis. A type 2 error is failing to reject a false null hypothesis. We can increase our chances of making the right decision by increasing the power of our test. Power is likelihood that we will find a significant effect when one exists. The factors that affect the power are sample size, power difference, population differences, variability, and on-4 level. Thank you for listening. In the next lesson, we will talk about the one sample t-test.